at the Global Climate Association are honored to welcome Rob the Lion to our Terra Torrent, a dialogue series, an integral part of the Terra Confluence 2024 event, marking the Earth Week this year. Rob the Light is a climate strategist and principal member of EcoRestoration Alliance and Global Evergreening Alliance. With over a quarter of century of experience, he combines his expertise as a practical philosopher, entrepreneur, and dedicated solution maker to confront the urgent global challenges of biodiversity loss, climate change, and food scarcity. As a near future futurist, he emphasizes the importance of this decade for taking bold steps towards sustainable living with fairness and respect for all life. With the vision to implement pump principle across the planet, Rob inspires global communities towards eco-centric strategies for a sustainable future. His passion for sustainable soil and water management is a vital contribution to our discussions on innovative solutions to current challenges faced by Earth and the environment. We welcome you, Rob, to our session today, and the floor is yours to share your views.
Thank you, Dr. Kolomi, for having me here. It's an honor and a pleasure. And so if you allow me, I will also share a presentation that basically shows that we can do a lot more, and really a lot more, to reverse climate chaos, which is of course accelerating around the world, but especially in the tropical zone, for the very simple reason that most sunlight comes into the earth at the tropical zone. So the impacts of the Earth energy imbalance, which we see right now, is largest in this area and also in the Arctic, but that's actually secondary effects from what's happening in the tropics. So let me see if I can find the presentation.
Sure, go ahead, Rob.
And now I have to do something. There's so many things here that it's very difficult to find the buttons because other buttons are in front of it.
Yeah, there's a full slide show that you can do. You can go to the bottom of your screen, and there's a sort of a
Yeah, but to get it going, to start it, so
you, you
the
can also
command that I have to give is there is something in between. Well, let's see if I
yeah
can
you
get rid of this.
oh
No, I don't think that's possible. So it's a very silly thing, but I can't click a button because there's something of the other apps in front.
it happens.
Oh, wait a minute. Now I think I can. No, no, okay. Oh, finally, I have to fix that. Okay, I think you would be able to see my screen now.
Yes, it's perfect. Please go on.
Okay. All right. Well, you've already introduced me, so let me just go straight into my story, which is called Green Up to Cool Down. And we want to unleash a global movement for regreening the planet, and we'll see that the impacts of that on both extreme weather events and on temperature of the planet is much larger than right now is realized by the climate movement. I'll go quickly through this, but I guess most of the people watching this already understand that this is going to happen if we are not, and is already partly happening. And if we are not reversing the course we are on, our planet will become uninhabitable for complex human societies with large number of humans. We will go into ecological collapse and the massive loss of biodiversity. We'll see more and more severe heat waves, droughts, floods, and storms, which affects food and water scarcity, leading to famine and resource conflicts, which is already happening in parts of the world. Right now in Southern Africa, there is a record drought, which is caused by all the effects of climate change, which already is bringing the lives of about 20 million people in danger. Just something from the last few weeks, but these things are happening quite a lot. It usually happen to people who don't have a lot of voice because it's quite often in rural tropical areas. So we know about the sea level rise that will make life difficult on the coasts. And the accelerating warming at some point gets into feedback loops, which actually increases the process even more. We have to think of this as an exponential process until basically our human activities are collapsed and the earth will regreen itself. So we're looking at increased conflict, mass migration, and the collapse of societies if we don't turn this around. I don't think life on Earth is in danger at all. It will recover pretty quickly when our numbers are down. But the aim of our work is actually to get through this evolutionary bottleneck with all of us. So the reason why human activities have started to deregulate the climate is because we have destroyed half of Earth's living biomass in the seas and on the land. We have removed so much. And this is actually really destabilizing life's climate. So while greenhouse gases do play a role in heating up the planet, CO2 is a problem. The larger problem is actually the deterioration of the biosphere on our planet, which I hope to explain in a few slides down. So right now, we're looking at a climate story that is only focusing on greenhouse gas reduction and sequestration. And that's a simple story, but it's incomplete and it will not do the show. It will not work to reverse climate change. If we add another powerful leg of reversing climate change, and that's reversing the destruction of the biosphere, we really still have a chance to avert the worst. So the fastest way out of climate chaos is what I call climate repair. You can repair the climate through the weather, the temperature, and the way the atmospheric dynamics work by doing things on the ground and in the sea. So in order to understand this, I would like you to imagine, I see the text is a little bit out of the slide, but anyway, I would like you to imagine walking through an old growth forest. I hope many of you still had that privilege because they're becoming rare. But then when you walk through it, you feel actually that the atmosphere inside is very protective. It's not too cool, it's cold, it's not too hot. It touches the skin in a very wonderful way, and it protects you from storms, heat waves, and heavy rain. And this large system also, when rain falls on it and percolates into the soils, it actually creates crystal clear, drinkable water. It actually cleans up the environment as well. This, especially tropical rainforests, have been developed over hundreds of millions of years, exactly designed to create the conditions for life to thrive. Now we're going up out into space. Going up, we rise up from the Earth's surface through the atmosphere, and here you see a picture of the sun just going down. A picture from the NASA spaceship, and you see the very thin layer of gas that is protecting us. The atmosphere is a very thin layer, and it is comparable to the human skin in the sense that it protects us from the violent space out there, which is very cold on the dark side and very hot because of the bombardment solar radiation on the solar side, and it protects us against meteorites and all kinds of forms of radiation. This gaseous skin of the planet is the product of the biosphere. We all know that we are alive because of oxygen, which is created by the biosphere, by trees, by small photosynthesizing creatures in the oceans. But also CO2 and nitrogen are recycled by the biosphere in order to keep the atmosphere in an optima forma to protect us. So we need to look at the planet in a different way and see that it functions like a living organism, just as your and my body. And it regulates its own temperature, which is now, of course, being deregulated by us. But how does it do it? Well, the big driver is the genius process of photosynthesis, which basically uses sunlight to make sugars and oxygen in the process, which gives all life, all animal life, including us, the possibility to live. But it does a whole lot more. And the part that is forgotten right now, which is actually the reason why we can repair the climate, is the fact that with every molecule of sugar that is made, also several hundreds of molecules of water vapor are released together with aerosols. Now, what does that mean? You need a lot of energy to get water molecules from the liquid state to the evaporated, the gas state. And this process basically sucks energy out of the forest floor, out of the Earth's surface, packs it into this heat, which is called latent heat, and that air rises up. Now, when it rises up, together with the particles of the aerosols that are going up, which are also released from and by the leaves, they create raindrops. So the clouds that we see above are made by the forests. Of course, over sea, that process happens also through evaporation, but here it happens through evapotranspiration of the leaves of plants, and especially the forests. And the best ones are the tropical rainforests, which are basically the cooling organs of the planet. So once this moisture goes up and forms clouds, a lot is happening at the same time. First of all, those clouds make rain, so they irrigate the land under us. 70% of all rain over the continents is made by the biology of those lands. Only 30% comes in from the sea. The second thing is it actually brings wind. Why? Because the moment that water vapor collapses into liquid at cloud level, its volume shrinks by more than 1,000 times, making under pressure, which basically sucks up air and also pulls it from the side. So especially coastal rainforests, coastal forests, all forests on the coast actually pull in moisture from the nearby oceans, bringing that onto the land. And this movement actually goes on into the interior as long as there is enough canopy of trees to recycle this moisture. In the Amazon, a drop of rain falls about 6 to 7 times before it leaves the forest on the south and southeast side, because it's a rain machine. And the last part, which is very important, the moment that you have this collapse of the water vapor into liquid, the energy that was taken from the forest floor now is radiated out by by the water molecule. And that goes in a part of the infrared spectrum that does not get absorbed by greenhouse gases. So a large part of that immediately leaves out into space. Some does heat up that area, but that only heats up at that level, the so-called tropopause, gets whisked away by the jet stream and slowly dissipates out into space. So the whole system is designed as a heat pump, uh, basically taking heat from the forest floor to cloud level and then radiating it out to space, cooling the planet. Well, actually, this is more or less what I've already told. So I will pass this slide for because of time restraint. So if we conclude the talk that I said, so forests cool in many ways. First of all, through this evapotranspiration through its leaves and its recondensation at cloud level, and then the radiation of heat out into space. This is not in the climate models. It also brings cloud forming, and clouds are white at the top, so they're reflecting sunlight back into space, which is another other cooler. It also shifts solar energy from so-called sensible heat to latent heat. Latent heat is the heat packed in these molecules that go from liquids to vapor, and this heat is not absorbed by the greenhouse gases. While sensible heat, the heat that you feel if you walk past a hot wall on a sunny day, is the heat that actually radiates from that object, and that gets amplified by CO2 and by water vapor as well. So the greenhouse effect depends on what the surface is from which the sunlight radiates back into space. If it's in the form of latent heat, it doesn't heat up via the greenhouse gases. If it's in the form of sensible heat, it does. Of course, it sequesters carbon, and that helps, but it's a small part of the total equation. And it increases the biotic pump and inland precipitation, increasing biomass production inland. Basically, the biotic pump, pulling in moisture from the ocean, is the way how forests have colonized and later stabilized the vegetation on land. So here's a big picture. You see the daily movement of clouds, and now you see the Congo rainforest, and you see that those clouds cycle is happening during the day, every day, which actually does all this work that we just talked about. And it's very important. You see a few Spanish words here. Sorry, it's from a Spanish version of the presentation. But if you look at rivers that are going through forested areas like the Amazon and the Congo or the less known Yenisei River in Russia, the further it's from the coast, actually you see that precipitation goes up slowly. While in areas where there are no forests, precipitation from the coast inland goes radically down. You see on the right-hand side that in West Africa, the coastal areas receive 1,600 millimeters, and about 1,700 kilometers inwards, only 25 millimeters of that is recycled. While in the Congo or in the Amazon, you see that it's about 3,000 millimeters in the case of the Amazon at the coast, and 2,500 kilometers inwards, as far from the coast as you can imagine, it actually has gone up a bit. This is a picture from an area where I'm involved in reforesting a destroyed part of the Amazon. It's very destroyed, as you can see. And during this day, the temperatures hiked up to 42 degrees. These young men are actually doing the hard work of reforestation there. But it's still early. It wasn't 42 degrees yet. And nearby, just a couple of kilometers down where the forest was still intact, that day we only saw a temperature of 25 degrees centigrade. Now, That difference of 70 degrees is very, very high. Usually you would see a difference of about 10 degrees, but it's still incredibly large difference between the open area where forest is destroyed and the place where forests are still intact. If we look specifically at India, the challenges that India has, and it is one of the hotspots in the world where climate impacts can become extremely lethal within just a matter of years. We already see an intensity of floods, droughts, and heat waves. We see an increased frequency intensity of cyclones, especially from the Bay of Bengal. We see damage to infrastructure and housing. Um, we see that large cities like Bangalore, Chennai, and many other districts, and Delhi, for instance, have problems with their water supply. We see more and more local desertification in places where it didn't happen. Impacts on agriculture, fisheries, and food prices are pushing these things up. These are slow rolling effects, but actually they work like a juggernaut, slowly, basically depleting the resilience of people. It shifts monsoon patterns and summer rains. It increases glacier melt and landslides in the mountainous areas. It increases energy demand for cooling at peak temperatures. It increases coastal erosion and saltwater intrusion, which is already a problem in many parts of the coast. It deteriorates ocean biology, including overfishing, which has also effect actually on land. And it restrains government resources for disaster management and etc. And sea level rise threatens many cities, including Chennai, Kolkata, and Mumbai. So, if you have a climate repair plan, what would it mean? First, you do large strategic reforestation programs at crucial points. Secondly, a large-scale shift to agroforestry, a form of food production that actually increases the income of the farmer. Um, you do regional climate resilient landscape design. So you make plans for large regions, for instance, a whole watershed to see what needs to be done in what kind of work needs to be done. You need to do this watershed and river-based management, collaborative mangrove and coastal forest reforestation programs that had all kinds of beneficial effects, both as nurseries for fish stocks, but also for the biotic pump I just told you about. It helps a lot with biodiversity. It's a shock absorber for cyclones and tsunamis. So you have to have an integrated disaster preparedness and response mechanism that brings the right resources to these places immediately after something happens. You have to move to climate resilient agricultural practices, which is a topic I could talk about for an hour long. And we have to do urban regreening programs, bringing down temperatures in the cities substantially and actually increase the rainfall over this area, having all kinds of beneficial effects. So, well, leading to, I already told a couple of things. It will stabilize regional weather and hydrological cycles. It will actually dampen severe cyclones and reduce the risk of natural disasters, lower maximum temperatures, which are already getting extremely dangerous in parts of India in the summer months. It will result in more regular river discharge through the year of basically all rivers. There will be more snow on the Himalayas, which actually reverses some of the melt that's going on, which is going to be a disaster in the decennia from now. You will get more energy security and lower emissions because the temperatures go down. You have improved water security and quality, enhanced agricultural sustainability, and more affordable food. and a new climate-aware generation that really sees the possibility of acting to make these things happen. So what I propose very simply and very audaciously, I would say, is first of all, draft climate repair plans as addition to state climate action plans everywhere, all states. And the second proposal is to add a ninth mission to the National Action Plan on Climate Change, which would be the National Mission on Climate Strategic Climate Repair. Here are just some of the possibilities that you can apply depending on the area. Silvopasture is a way to actually have cattle and livestock rearing together with trees, which helps also this hydrological cycle. Agroforestry is clear. Water boons is a technique that with which we can reverse deforestation very fast. Farmer managed national regeneration, actually, it's a technique that has been developed even where forests are taken out. The tree stumps can be revived even after decades. So it's one of the fastest ways and one of the cheapest ways to regenerate forests that have been cut, let's say, in the last 50 years or so. Thank you for listening, and this is the end of my presentation. My details are here. If you want to reach out, please reach out to Kolomi or to me. We are happy to talk about it because this is crucial, actionable research that can help us stop and reverse climate change.
Thank you so much, Rob, for your enlightening presentation. And now to discuss further, I would like to move on to our next part of the series, which is where I ask you a few questions related to the presentation that you make to make it more encouraging and enlightening to our the people who are going to listen to this uh, dialogue series videos. So the first question that I have for you is like what inspired you to focus on ecosystem restoration and sustainable agriculture, and how do you envision these initiatives impacting climate change mitigation? I know you have already spoken about what your idea was, but then was there a specific reason that you chose this field to work in?
Well, I started as a climate activist actually after I'm an entrepreneur and I sold my company, and I realized the big problem of climate change. And when I basically had time again, because being an entrepreneur is a 80-hour week job, I realized, and I really literally said, they haven't done anything. And that was in 2009. And I got such a shock by that that I basically started saying, well, we have to find solutions. The best solutions I found were actually because I bought an area in the Brazilian rainforest which had been destroyed, and I started to do the reforestation myself there. Without any knowledge, actually, I just went in there and started planting trees and doing uh, water management, which basically is digging holes. It's very simple stuff. And within a couple of years, it was a small valley. And so I could see in this valley, I could see the enormous changes that happened just because of my silly little actions and not destroying any more nature because nature is very resilient. So within a couple of years, the temperature just in this valley would go down, and it would become more humid, and especially springs came back. We did especially reforestation around dried out springs. And within 5 years, they started to give water again. So I didn't really understand, but I was very hopeful and optimistic. If I can do that with complete lack of knowledge, just going in there and do whatever I have to do and see these results, imagine if you would do this with all the expertise that's out there. So fast forward, I realized that one of the biggest threats to global climate change was the basically the dieback of the Amazon rainforest. It's in a tipping point, because rainforests need a lot of rain. And if the biotic pump stops working, then basically the forests dry out, and it's an exponential drying out and dying back of trees. And the Amazon rainforest is the largest cooling organ of the planet that has that spreads its atmospheric hydrology all the way up to as far as Greenland and southern Africa. It's basically, you could say, it's a La Nina in the sky that is produced by this forest. So if that goes, the whole temperature regulation of the earth and would be completely out of sync. So talking about to people there, and we did some reforestation, not enough. We only planted 1 million trees, while you will need a couple of billion. But anyway, you have to start somewhere. And so this really inspired me that we can actually do very locally, see great effects on the ground pretty fast. And I built up my knowledge, my network, and I think basically I have a message to the world right now that we can fix this.
This is the positive inspiration that we need, like from people joining hands from all across the world and taking simple actions. This is not something where we require a lot of technology, a lot of maybe knowledge and expertise. This is something simple that everyone can do, and then you have been like doing that, and that is a great inspiration for us all. So thank you, Rob, for this. And then moving on to the next question, which is basically on the biotic pump principle. I would like to know that in light of your work on ecosystem restoration, how do you perceive the pump principle, which was theorized by Anesthesia and Victor, in practical environmental conservation and climate change mitigation? So, could you share your thoughts on integrating this principle into your current or future projects? I ask this because was somewhat of a controversial topic which not many people want to discuss about. So, how is this
Yeah.
principle going to help us?
Well, actually, it's crucial if we want to win this fight against climate change. Understanding the biotic pump principle phenomena, I should say, it has been proven by my friend Peter Banyard in a series of experiments. Um, okay, so all rains, the rains that are brought on land basically are largely brought on land by forests, by coastal forests. That's where the cycle starts. Now, humans like coasts, so a lot of our infrastructure and cities are on the coast. So you remove your trees. Now, what you have actually is that, so if the biotic pump is working, so then you have that evapotranspiration and cloud forming, which brings in this under pressure and it pulls humidity from the ocean. If you take away the trees, actually the opposite happens because when that area heats up, it basically blocks any winds coming from the oceans. So the humidity is not being pulled in over the continents. So I've been talking with people to actually have a map full of what I call acupuncture points for starting the regeneration of forest, which then would pull in precipitation over the lands. But you always start at the coast. Doesn't mean you have to remove everything that's on the coast. We can't. But if you have, let's say, good canopy cover over a city area or an industrial area, it will still, you don't need 100% canopy cover. And we don't know exactly. It's a fast evolving and emerging science. But I think if you would have as much as 60% of the land over the coast, which would have is covered by canopy, that already will pull in this moisture and start this precipitation inland. So it's crucial.
So, according to you, Peter Barnard's work, this is instrumental and also sort of something if people follow, the change can be the global warming's speed can be really curtailed to a limit where we can do something about it. Because his work is like exceptional in that way, where he explains if we just follow the biotic pump principle, we can do so much to if not completely stop, halt, but slow down the global warming issues that we are
Well,
having?
if you allow me, actually, we published an article just last month where we did the calculation. I must say that Peter Banya did the heavy lifting. He's doing work way above my pay grade. But what is happening? Oh, the light is going out, so it's getting a little dark here. Anyway, but we figured that if you would regenerate degraded land and deforested land over an area of 280 million hectares in the global south, in the tropical zone where the impact is biggest, the total effect would actually be a cooling of zero point 0.9 degrees centigrade of the total planet because of the heat pump effect of the additional evapotranspiration. And now 280 million hectares is a hell of a lot, but 100 million hectares has already been removed just by in the Amazon forest area alone. So it's doable. And it has all kinds of benefits. And agroforestry systems, which have different level of shade trees and lower bushes, have similar evapotranspiration effects. So it includes also a new way of producing your food in forest-like situations. So it's not slowing down; it's reversal global warming, in fact.
So what you call the climate repair in totality, that will happen if we do this.
Yes, yes, yes.
That is great. So now, moving on to the third question that I have. So, in your experience, what are the biggest challenges that you have faced or you're facing in implementing these large-scale reforestation and sustainable agricultural practices? I ask you this because you have yourself done it in your, like you did the reforestation program yourself in the Amazons, and what are the challenges that you think there might be there?
Well, the problem is always humans, and because if nature would actually regenerate itself if we stopped hacking away at it, um, I would say, first of all, governments are always very much focused on technology and that kind of things, but nature is a hell of a lot smarter than humans. But humans don't like to admit that. In fact, when I'm proposing reforestation programs, I always say, okay, throw in a couple of drone seedings because boys will be boys. They need their tools. Otherwise, they don't take it serious. Because what happens is, what needs to happen is in areas where people have no voice. It's the rural areas in the global south, completely ignored by the world economy, while actually they produce, I think, something like 70% of the food in the world. So it's we need to refocus. Then, of course, there's the usual stuff of greed and ignorance, which is pervasive and is leading us straight into the abyss. So I don't have a direct. I know how to reverse climate change from a technical point of view, but it's far more difficult to manage what needs to happen in society, culture, and economy in order to get this big change.
Because, I mean, I would like to add to that because there's also a population of more than 8 billions that our world is having. So the reforestation or the regeneration program has to be intertwined with the built up that we are, the infrastructure that we need to sustain the humans and their activity and the other organisms as well. The other species will thrive with more natural world, but if you talk especially in countries such as India or other developing nation, the need to keep developing to bring them to a state of developed wants to uh, be in a way people are doing it in a way where they're focusing mainly on infrastructure. So the forest or the
Yes.
old wood forest, especially even it's happening in Canada because there are like more than thousands of years old trees are like cut down to make way for anything that is more human made or for a structure for housings. So that has to be
Exactly.
kept in mind with this
Yeah,
inter.
the economic boom in India, of course, is largely driven by by things like the IT industry. And don't get me wrong, it's very important. But the basis of a good climate, but also of the food production, are the, what is it, 300 million smallholder farmers in India. And if we would finally give them, um, we would honor their work and also pay sufficiently and pay them to do the transition to, for instance, agroforestry, um, their income would at least double. We have clear examples on the ground where that has happened in, for instance, Andhra. And so we would improve our climate, our weather, and our water situation, and our food production stability by actually putting these people in the center of climate action and honor what they can do, because they understand still what you can do with soils, and that's very important.
That is true. That is quite interesting. And how crucial is community involvement according to you in these projects? And what strategies would you suggest for community level participation for these reforestation schemes? Or,
Well, I wrote a whole plan to do this. It's called the Arara plan because it's that's an Indian, that's a Brazilian word for indigenous word for the big colorful parrots that we have over there. But it would apply, for instance, all in the Indian context. Basically, okay, you have to do this this dissemination of this of these opportunities within the local communities, but you have to support it first of all by digital tools. Get everybody on the internet and let them put their projects on the internet, and basically let there be a design of how they would like to transition, let's say, their 10 hectares or so. And then if that plan is designed and agreed upon, then they would get the transition finance. And once you start that everywhere, you see that if these things work and people make more money, then they start spreading themselves. But we have to have community-based action, but supported by digital infrastructure, financial infrastructure to get it at the speed that we need, because India doesn't have that much time. Wet bulb temperatures will reach actually in the next month or so already levels that if your power grid goes down, basically is lethal to a lot of people.
true, India is suffering, and we are having one of the hot periods right now where the temperatures are soaring. We are, I think, currently having more than 35 degrees, 40 degrees in the where I am staying at right now. So, and especially till the time we reach 2030, a lot of changes is going to happen, and that all are adverse impacts of um temperature rise and then drying up of groundwater. So things like this need to be done and done fast for us to be means for our survival basically. So
It's true, but we can. I mean, this is doable. Let's say tomorrow Modi decides to give 300 million smallholder farmers the finance and the tools to transition their food production in their area, or at least a part of it. The effects would be noticeable within 5 years.
so we have to proceed with the climate repair plan, not just for India, but for the entire world. So
Oh, absolutely. But India is at the forefront of this battle in
mm.
terms of impact, and also with its huge population. Also, India has shown time and again that it can change itself and very fast once somehow that movement is going. Whether it was through Gandhi or it was with the technological economic revolution we're in now, it can do it again. So I think it would be one of the most important parts of the world where this could happen very quickly.
To set an example, so as to say. True. So, moving on to the last couple of questions that I have for you. Um, in global context, and means you already told about India. In global context, how can these principles and practices be adapted? And also in terms of sustainable agriculture techniques, not just the biotic pump principle, but these agriculture techniques. So all in all, how can these applications be adapted by different countries? And would you need some specific government intervention or help or support from the governments across the world to make this happen?
Yes, I'm actually developing a plan, and I'm looking for support that the G20 actually would take this as a priority in their action plan. Some of the major again, most of the repair with largest impact has to happen in the tropical zone, because that's where the effects are largest, both in degradation and and once you regenerate. So there is actually a G20 a global land restoration plan with very large ambitions, a couple of 100 millions of hectares to do that, and that's exactly the size we need. And so if we could, India actually did a conference and some work on it last year when it was the chair. Now it's Brazil. Unfortunately, Brazil dropped the ball on it, and I'm still hoping to talk to the government if they could still do this in the second half of the year to show these mechanisms. And then next year is South Africa, which is actually reeling from enormous droughts. So all of them, it would be very beneficial for three global South chairs in a row to get this ball moving.
That is true. And what would be your the to move? This will be my last question to you for this session. And considering all that you have done so far and you are going to do so far, especially with working with governments all across the world to create a climate repair plan, and what advice would you give to individuals or organizations looking to contribute to ecosystem restoration and sustainable agriculture, not just in country wise, but globally? What your advice would be?
Well, first of all, anybody who thinks there might be something into it, really just focus on the solution. We all know that if you are under a tree, it is cooler, but that's not just the shade, it's actually the active work of the tree pulling energy out of that space and puts it into evapotranspiration, which then has all the effects that I told. So internalize the fact that you are looking at a natural air conditioning system and the importance of it. And then picture the whole planet as one integrated superorganism. And from there, basically action roles. Because every square meter that can be improved in terms of its climate impact, a square meter of of black asphalt heats up. A square meter of green land actually cools down. So this is very actionable for everybody. So it has to become a movement. Governments and institutions need to finance the most important parts, but in the end, if it becomes a movement, it's hopeful because everybody thinks right now that we're going down the drain, and the only thing we can do is to slowly stop the sliding into the abyss. But it's, I'm telling you, is different. You can turn this around and fast. And if we all feel that, an enthusiasm and optimism will prevail, and the young people right now can take over the leadership of greening the planet.
Thank you so much, Rob, for leading the way towards a climate repair future for the entire world. And I'm also going to extend a heartfelt thank you towards Peter Barnard, whose work has inspired a lot of action that is happening in this field. And this is it for our session.
For all the work you're also doing at the Global Climate Association.
Thank you so much.